welcome to another edition of Pyvo. Finally inside, finally with some speaker. Hey, this is our speaker. As per always, after the summer, it is a little bit slower here, but we get used to it very soon. Next month, we're going to be so much faster. 70 people, we start at 7. This month, it's just fine. Speaker is also very shy, so that's why we're trying to be very careful. Good. Yeah, so before we start, a few of the little organizational things. There's going to be a burlesque show on the other side, and maybe I shouldn't just advertise it like that, but ideally if you need to go for a toilet, please use the door before the bar. You know, to avoid all the temptations. So you return and don't disturb. Second thing, yeah, anytime feel free if you're a little bit thirsty to grab a beer, because obviously Pyvo. And if anyone has a lightning talk, make yourself known as soon as possible. Is there a lightning talk coming in? No. Yeah, but there were some little pushes. We'll see by the end of the session. Yeah, and we always look for new speakers. So if you would like to be like Patrik today, you know, the hero of the day, the hero of the month, then just ping us, visit Discord, send a message, tell us afterwards. We're so grateful. And if you would like to organize something like this, or just be instead of me, I would so appreciate it. Then also let yourself known. But without further ado, right, Patrik, we can go.
So, hi everyone, my name is Patrik. I'm a reformed Bash programmer and I've come to like Python with its cool features like async.io, MyPy, and I mostly write code that looks like Java. And I also like cybersecurity and privacy things. So I'm going to talk to you about FastAPI today and why you should care. Well, FastAPI is a library that promises to be fast. Unfortunately, it doesn't always deliver unless you try. But it allows you to write concise code for your API servers. And it also uses async.io under the hood. So your code will be fast and non-blocking, all that fun stuff. And it also uses the typing system, like type hints, type annotations. So your code is easier to read and navigate, and you make less mistakes when revisiting the code, because your IDE will be helping you. So FastAPI uses a library called Pydantic under the hood, and it's used for creating models of the data you will be using. Like for example, for the data you will be accepting from the users, you can model how the, for example, JSON payloads should look, like what fields they should have, how they should be named, and what data types each field should contain. You can also put constraints, like the maximum length of a string for a field, number ranges, like for example, this field should be between 0 and 10. And it also is used for describing the format of the data that you will be returning from your API in the same way as the data that you accept. Another cool thing that FastAPI handles automatically for you is API documentation. It's using Swagger UI or Redoc libraries under the hood for generating HTML docs that are accessible at the /docs endpoint of your web application. And it looks pretty by default. And the Swagger and Redoc documentation is powered by OpenAPI standard. This is a JSON file that describes all the data model that you wrote using Pydantic, and all the path arguments for your endpoints, query strings in the URL, form data, whatever you can imagine that a JSON API should accept. And OpenAPI is a machine-readable API doc format. And since it's machine-readable, you can also use tools to generate client libraries for your API. For example, you write your server in Python, but you want to use it from a Node.js application. You use an OpenAPI generator to generate a library for Node.js that will handle all the data models for the user of your API. So, getting started with FastAPI. First, you need to install it, obviously. And the documentation recommends that you install all the optional dependencies, which include UVcorn, which is a ASGI web server that's used to actually run your application, because FastAPI does not include a web server in itself. You need something to run it with. This is ASGI stands for Asynchronous Server Gateway Interface. It's an evolution of the WSGI that you may know from non-async.io Python. And another thing that the optional dependencies of FastAPI include is faster JSON encoder and decoder libraries. One is written in C and the other is a Rust implementation. You can pick whichever you like, but you need to explicitly opt into using them. By default, it uses the built-in JSON library in Python, which is really slow compared to these two. And you also get some extra things for Pydantic, for example, for validating email address formats and some unit testing dependencies like HTTPX that help you write unit tests for your application. So, writing a Hello World application with FastAPI. First, you import the package that you just installed. Next, you create an API object. This is an API object now. And now you can start creating your API routes. For example, here we create a get route for the root of our web server. And we specify that it should return a string-to-string dictionary. And we do just that. Return hello world message. This @ sign is a decorator. It's a normal Python thing, and it allows you to wrap one function inside another and do all kinds of stuff with it. FastAPI uses this for adding your functions to the application routing table, pretty much. Don't worry about it, it just works. So, this API object has several methods. One of them is get. This allows you to specify the type, the HTTP method for the API route endpoint. And by default, this takes at least one argument, which is the URL path that will be served by this function. So now that we have a Hello World application, let's run it. As I mentioned, we use a separate web server to execute our application. So here's the command line that you use. UVcorn is obviously the server program. And then you need to specify where to find the application you just wrote. So you can specify the module, where to find it. Can also be in the dotted notation like package.module.submodule. And then after a colon, you specify the API object you created. And the reload option is just to watch for code changes and automatically restart the web server, so you can hit Control Save in your IDE and the application automatically refreshes. You don't have to kill this command and run it again. And it outputs some logging lines. You can find the thing to click here. And it opens your web browser when you click it, but we don't want to do that. We want to test it using curl. So here's the command to run, and we get the JSON. It works. And one of the cool features that FastAPI has is called dependency injection. You may know this from other languages, like Java uses this very often. It pretty much allows you to easily share things between your API routes functions. The main thing that it does is reduce code duplication. And you can inject both normal and asynchronous callables like functions, methods, and even classes into your API routes. And since Python 3.9, there's a cool feature inside the CPython or the Python's implementation that allows you to annotate types with extra metadata. And FastAPI uses this to make your linters happy and your IDEs resolve all the things that you pass in as dependencies, so it knows what kind of return type your dependency functions or classes have. And these dependencies can also be very easily overridden when you write unit tests, so you can substitute a different database connection because you don't want to connect to your production database when running unit tests, or do other things. Like whatever your dependencies are, you can easily change them when testing. So how does using dependency injection look? First you have the usual imports. Then you write the thing that you want to depend on from multiple API endpoints. Here we're just returning a simple string. This can be, as I said, asynchronous function, normal function or class. Then you annotate the return type of the function and assign this to a variable that you can later import inside other modules that will define your API routes. And what this does is it adds the dependency as metadata to the string type. So when FastAPI sees that you want this word of the day dependency with the camel case, it will be able to load it by its type. So for example, here we have two routes. One gets you the current word of the day, and the other gets you the same word but reversed. And you can see this dependency was injected by its type. Does that make sense to everyone? Well, yes? Okay. Oops, what happened? So now that we have the basics covered, let's do something useful. Here's the same QR code that was cut off from the slides in the beginning, so if you want to scan it, feel free. No? Okay. So, what do we want to write as an application with FastAPI? I picked to make a catalog of virtual pet snakes, because why not? And such catalog would need to have a few features. For example, we want to be able to add new snakes into the database. We want to get details about the snakes we create. we want to get a list of all the snakes that we created so far. We want to make something cool with the snakes, for example, make them grow. And finally, we might want to also delete the snake. And you can figure out whatever you want. So, first step, we want to model our snakes. Snakes usually have some attributes, for example, the species of the snake, its current length, and whether the snake is venomous or not. So we will pick these to track in our application. And now it's time to write a Pydantic model for this. So again, first step, we import a base model class from Pydantic package. Then we declare that we want to subclass it. We declare a species field that will be of type string, and add a description that will be shown in our API documentation. We also specify some constraints for the species name. For example, the name of the species probably would not be shorter than 3 characters, and it probably shouldn't be too long. Also, now we can give some examples for our API documentations and add the length field, which we will track as a float. Again, description, some constraints for the length of the snake. It shouldn't be negative, and we also don't want to allow users to add snakes longer than twice the longest snake ever found or recorded. So we kept the maximum length at 20 meters. And again, we give some examples, for example, 3 meters or 3.6. And it's finally the venomous attribute, which will be a simple boolean. Again, description, examples, you don't really need those. So this looks like we will gonna need a database to store our snakes, right? And databases usually need a primary key. We didn't add any such thing, at least relational databases. So it's probably time to draw a database diagram for our snake model. Here is one. All we did was add the ID field, which will be the primary key for our database. It's an integer. And now we look for an ORM library that provides some kind of FastAPI integration. ORM stands for Object Relation Mapping, and this is a thing that allows us to represent database tables and rows as objects in our application. One such library is SQL model. It's from the same guy that wrote FastAPI, and it builds on top of Pydantic, so we don't have to throw away the model we just wrote. And it also integrates with SQL Alchemy, which is a pretty popular ORM library for Python. And it allows us to interact with all kinds of SQL databases, for example, MariaDB, MySQL, Postgres, SQLite, and many others. So time to add the ID field to our snake model. The only thing we need to change is the base class for our snake class and add the table argument to the class. It's not a constructor. Not sure how this is exactly called. It's a
Argument? Definition?
Yeah, probably. So we add the ID field, which is an integer, as I already said. This will be the primary key in our database for this table. And we copy over all the fields that we have specified so far. The only minor change that we had to do because of switching to SQL model library is moving the examples slightly, because it's no longer accepted as a keyword argument for the field function, probably. So yeah, that had to move a bit. It will probably be fixed sometime in the future in the live SQL model library. But we don't want to manually assign IDs when we create new snag objects, but we specified it as a required integer attribute for the class. So we could make it optional, because a database generally knows how to auto-increment its primary key, right? We do just that, make the integer optional. But now we have a weird type annotation for the ID field. We need to handle it being none in all of our code, even when we just read it from the database, which does not allow a null value for the primary key column. An elegant solution to this is to separate our input and output models, which inputs is when we want to create a new entry in the database, and output is when we read out an entry from a database. So let's do just that. Again, we have our base model. This specifies only the three attributes that we started with, not the ID. And we subclass it, add the ID, optional ID attribute, and this will be our database table model. Then we subclass the original model again. This will be our input model, which will not have the ID field. And then we want the output model, which will again have an ID field, but this time it's mandatory. The one with the optional ID is not user visible, so it will not appear in our API documentation. And the create and read models will be added to our documentation, and they'll obviously inherit the species, length, and venomous fields. Yes, and how do we convert between those kinds of objects? We have the field description documented and all the database queries. Yes. So when we don't specify the ID for our creation model, it will be null in Python, but once we pass it to the database will fill it in on its own. And to convert between those two, when we need to, we do it like this. We import our base model and the output model. We create a synthetic snag that we pretend we just read from a database. This will have the mandatory ID, and try converting it into the read model. This is done using the from ORM method of the object, and it succeeds. It returns a snake with all the fields pretty much copied from what we entered from the database. But there's something off in the syntax highlight, right? Why is the ID field green? It's the Python's built-in ID function. Linters usually don't like when you do this, so we should probably do something about it. One way to do this is rename it to something else. For example, add an underscore. But we don't want users to have to enter the underscore for the ID, because JavaScript doesn't have this restriction as Python. So we add an alias to the field. And alias is the thing that will appear in all our API documentation, while internally in our Python objects it will still be with the underscore attribute. We again try converting the objects between each other just to make sure we didn't break anything. Create a synthetic snake and try to convert it into our output model. And we get a traceback. Validation error. ID. Field is missing. What? So we need to add an extra configuration to our base class, the base model class. This is a feature of Pydantic, and we allow populating it by the field alias. For some reason it's called populate by field name, but it's an alias. We tried it again. Now it works again. Oof. But we probably don't want to return just the snake models from our APIs. We want to also output some messages, like when we make the snake grow, we want to output by how much it has grown. And we want to do this as a simple string. So let's create an operation result model that will contain the result field, and it will have a string value. Easy. This doesn't need to be stored in the database, so we inherit from the Pydantic's base model class instead of SQL models. We don't need to really specify any constraints for the result string here, like the maximum length allowed, because we will be generating this on the server side and never accepting this as input from the user. Oh, step 2. Now that we know we will need a database, we have a model for our database table, we will need to connect to some database. And we will most certainly need to connect to the database from multiple API routes or endpoints that we write. So we use FastAPI dependency injection. This is how that looks. Don't really worry about the database connection stuff. I will explain some of that later. But we basically just use a file database on the disk with SQLite. We also specify that we want to see all the executed SQL queries in our debug logs, because we're just developing the application right now. We're not worrying about leaking anything. And this check same thread argument is something you should not worry about right now. So we create our dependency that we will inject into our API route functions. This will yield us the database session that's already connected and ready to accept our queries. We annotate it, so FastAPI knows what to do when it sees this as an argument to one of our routes. And finally, we create an application. We specify that on startup we want to ensure that all the tables are actually present in our database. If not, let SQL model create them for us. But there's a small catch. You'll need to make sure all the models that you will be using are imported or in the same file, because this feature relies on subclass hooks. So if you store your models in other file than where you create these API objects, SQL model will not create any tables for you. So now that we connect to database, we don't want random strangers on the internet to mess with our snake database. So we add some authentication. There are many types that you can implement. For example, using the authorization HTTP header, which can be done either as a basic authentication, that's the username and password pop up in your browser, or using JWT tokens as bearer headers, authorization header, or using API keys, which can be passed as a query string via the URL, but this is generally discouraged because anyone who can see your screen will see your API token. or it can again be passed via an HTTP header, for example as a X API key, or as a cookie, which also is a HTTP header. Or you can choose to delegate authentication to a third party, for example via SAML, ZeroAuth, or OpenID. There are some disadvantages to those, but also some advantages if you use one of the modern ones and you don't want to worry about having your database of passwords stolen. But we pick the HTTP header API key authentication because it's easy. So we import some stuff again. We import security because we want it to be secure. We specify which header we want to store the API key in, and some API key that you can later load from a database for each separate user. For now we will just hard code it. And we write our dependency that we will inject into our routes later. And this dependency will accept the key, and this key will come from the HTTP headers. You can see it's annotated. And we will compare the key, and if it's not the one that we hard coded, we will raise an exception which results in a 401 error thrown to the client. Now we add an endpoint that's supposed to be locked behind authentication. We inject our dependency. You can see either can be specified as a keyword argument to the application object method, or you can also add it as an argument if you want to use the return value. This authentication function does not return anything. It only validates that the API key is valid, and that's all. If it's not, you will not get this far into the get secure function. And once the API key is validated, we will return a string to the user. So let's test it. First, we try it without the API key. It should fail, right? We get a 403 forbidden. This is done by the FastAPI on its own via the security class that we imported. So that worked. Now let's try specifying the real and valid API key and requesting the same endpoint again. And we get a HTTP OK return code and the string that's behind the authentication. So it works. Now that we have a database, authentication, and all the models, we can start creating our API routes or endpoints. So first, we want to be able to read a single snake from our database based on its ID. So we connect to the database via dependency injection. You can see that as the DB argument with the DB session type. That's what we created when starting out. And another argument is the snake ID, which is an integer, and this will be accepted as user input. On the path, you can see it in the decorator. There's the placeholder snake underscore ID in curly braces. And we also add a public tag because this endpoint does not require any authorization. And we now read the snake from a database. We use the get method of the database, which accepts the model that we want to read from a database and it's the primary key that we want to get, and it's either returns initialized object of the type that we requested or none if it does not exist in the database. So we handle the none case. If a snake is not in our database, we return HTTP 404. And if it is, we convert it into the output model and return that to the user. Yeah, and there's also some gotchas, like you usually in the FastAPI documentation, it's just like return snack, and FastAPI knows what type to convert your return value into, but this does not play well with type checkers like MyPy, so we explicitly convert the object into another type before trying to return it. So next we want to be able to create or add a new snake into our database. Now this is a privileged operation, so we add the API key requirement as a dependency and tag this endpoint as admin and not public. This time we also accept a new argument in our route function, and that's the request. This comes from FastAPI and returns all the current state of the connection and application, and also the request that was made to our server, so you can know what is happening. And we also accept the snack input model or the snack input format in this route. This will be posted as a request body by the client and parsed by Pydantic, validated, so it has all the right lengths and all the species name are valid. And if it is not, the FastAPI will fail the request before your function starts executing, so you don't have to worry about it. This reduces the amount of code you need to write. So once all the inputs are validated, we can start converting the data that we got into a format that's suitable for our database. So we convert the model into our database model, add it to the transaction, commit the transaction. This actually results in writing the data into database. And then we reload this row we just wrote so that we can fetch the ID that was assigned to our new snake. And finally, we redirect the user into to the get snake route that we wrote on previous slide. So he can verify that the snake was created successfully. Now for the unfortunate thing of deleting snakes. Again, this should be a privileged operation, so we repeat the same thing. Injecting the API key dependency tagging is at admin operation. And now instead of writing to the database, we will be reading from it so that we can fetch the snake by the ID that's supposed to be deleted. That's again the db.get method, which we previously used in one of the examples. And again, if the snake is not in the database, we raise 404. It does not exist. Now if it was found in the database, we delete it, commit the deletion into database, and finally return details of the snake that was deleted, so that the user will know if he deleted the wrong one by mistake, mixing up the IDs or whatever. Now that we have all the get and create and delete methods, we should probably allow the users to fetch all the snakes we have created without knowing its ID. So for this, we will put a list, we'll get to our root of the step server, tag it as public, and declare to return the list of the output snake model, the snake read. And now it's time to query the database. So we do a select, but we won't write the SQL query on our own, because this is an ORM library, an SQL model. So we do this by normal Python methods. So we want to select every snake models, which selects the table from a database. We order all the snake by their ID and convert them into a list to return into the output model, execute the query, fetch all the results. And now to making snakes grow. So snakes probably grow when they sleep. At least that's what I think. We don't want to restrict this to just the administrator with the API key, so we make it public because there's no risk of bad data getting into our database. This just increments the snake's length, which should be probably fine. Yeah, so first we read the snake that we want to modify from the database. Again, same thing, we read it by ID, raise a 404 error if it does not exist. And now we sleep for a bit. This is just to showcase that the routes can be asynchronous functions, and your web server will be able to handle multiple concurrent requests when you use async.io. If you instead wrote it as a normal function and did time.sleep, then this will block your web server's thread and no other users will be able to do anything until this request finishes. So now that the snake has slept enough, we will adjust its length, commit that to the database, and return an operation result message, which says by how much did the snake grow. But there's one thing that bothers me, and that's that we have been repeating a lot of the raising 404 error exceptions. So it's time to deduplicate. We subclass the HTTP exception class and hardcode some of the arguments that we've been specifying every time, so that we can easily reuse it in all the 3 cases that we wrote so far. So we modify this code, the previous code, to be just those 2 lines instead of 5 or 6. FastAPI also allows you to document some API endpoints that are deprecated. They will be grayed out in the web version of the documentation and also marked as deprecated do not use in the machine readable API spec. This is how you do it. We just add a deprecated argument or keyword argument to the method decorator, and you do all the normal stuff in your function. You don't need to modify it when you want to deprecate it later. Just adding this one keyword argument is enough. So, now that we've talked about the auto-generated documentation so much, let's actually look at it. It has pretty colors. Not sure if you can read it. And it's powered by Swagger UI, as I said at the beginning. You can also switch this to using the redoc library. Looks different, but it's the same thing. And even shows us that some of the endpoints require authentication. You can see that as the small padlocks on the right. And it also allows us to log in. This is how the login dialog works or looks. It knows what header to use and prompts you for value for the API key, which is secret. And when you scroll down to the bottom of the generated page, you can see that all the models that we created with Pydantic and SQL map are documented here, along with all their constraints like the string lengths and snake length limits. And you can also see that when creating snake, you do not specify an ID, but when API returns a snake to you, it always has an ID. There's also documentation for Pydantic's internal validation error class, so users will know how that looks. There's also our operation result, the string class. So we have the full schema for the API, which is cool. And Swagger UI allows you to also interact with the API from your browser. You don't need to install any utilities like curl or whatever. You just click the try me button, and when expanding the documentation for an endpoint, it shows you all the examples and the documentation strings that you wrote in your code. Also documents all the return codes and models for each endpoint. And it also shows you the commands to run if you want to reproduce this on other machine that does not have a browser or something. So for example, via curl, you can see that the full command here. It also includes the authentication header, which is not so secure anymore since it's revealed in plain text here. Oh well. And we also made some mistakes. We forgot to document some of the return codes for the HTTP API. We forgot to document the 201 code, which is the snake created redirect. So we should probably go back and fix that. And we do it via the responses keyword argument to our API route. We add the code and what it will contain. For example, we know that we return the location header with our 201 responses so that the browser will redirect to the newly created snake by its ID. Easy fix, right? And we should do the same for the authentication errors, like 401 and 403, because these are also not documented right now. And also for the 404 error when the snake is not found in our database. That's also not currently documented in our OpenAPI spec. But I will not show it because it will not fit on the slide here. So now, bonus API endpoint. Anyone knows how to do a proper search in a relational database that does not repeat pages when new entries are added or deleted from the database in between a user pressing next page? Yeah, that's called cursor pagination. So, our paginated responses will need to indicate what the URL of the next page is. We will put it in the link header, HTTP header. We will also describe this for the user to see that he will have to look there for a link to the next page. And we add some filters to filter our snakes by, for example, by the species name or part of the species name, or the minimum or maximum length for a snake, or whether the snake is venomous or not. So the users can query venomous snakes that are longer than 2 meters, no problem. And the pagination arguments for our endpoint will be offset and limit. Offset will contain the ID of the of the snake that should be included in the page of the next result. And limit will be the number of snakes to return per each page. We also document them with proper descriptions. And now to actually implement this. So we will be returning a list of output models for the snakes. We construct our database query. First we select the snake table. Then we add a where clause. Filter by the snake ID offset from the pagination, and do filtering on the species name. So here we use the contains, which is the %signs in SQL. Then filter by the minimum length if that was specified by the user, maximum length, and the venomous boolean flag. Next, we order them by the ID because we need this return values, these rows to be ordered for the cursor pagination to actually work properly. and we limit them by the specified page entry limit. Now we convert all the returned snakes into the output model to show to users. And if there were no result, or if there were some results, we add the next page link into HTTP address. Otherwise, we don't bother. And finally, we returned our snake list. Another cool feature that FastAPI has is that it allows you to logically isolate some of your subcomponents of an application. For example, here we have an API object which will include two sub-routers, one for the snack application that we were writing, and another when we decide to write the same thing for rodents, like mice or whatever. So it works pretty much the same way, but instead of instantiating app objects as a FastAPI class, we import the API router class. The API router classes can later be attached to the main FastAPI object, and it will all just work. You just specify the URL prefix that each of these sub-routers will be attached to. And yeah, when including them. So now when we fire a get request to the snakes path, we get the sound for a snake and squeak for rodents, which is exactly what we want. Now, some of you might also want to write unit tests for your application. Once it gets big enough, you generally are afraid to touch anything because it will break, especially if you haven't seen the code in 6 months. Unit tests are cool, but we don't want to modify our production database when executing tests. So we need to mock the database, like create a dummy database that we will add and remove entries from in our tests without affecting anything else. So PyTest has cool mocking capabilities via a feature called fixtures. It's exactly the same concept as FastAPI dependencies, only they're injected by the name and not type. And for testing, we will use an in-memory SQLite database. We don't need to write anything to the disk, so that we get a clean slate for every single unit test. This is how a basic unit test for a basic mock for the database session looks. We create a PyTest fixture that will be called db_session. This is, you can also skip the name argument, and then you will have pylint warnings because you are overwriting the global fixture when depending on these mock fixtures in your unit tests, or you could move them into conftest.py and it will also solve the problem. Here we will put everything in one file, so we need to rename the fixture and create a connection to an in-memory SQLite database. You can see that it's in memory because it does not specify any file name. Again, we use some thread safety things that you should not worry about. You can read more if you care. There should be a link, probably. No, not yet. And when creating this fake database, we immediately populate it with all the tables that should be present. That's the SQL model metadata create all, and return the database session that we created. Now we also need a fake application instance for the FastAPI object. And it depends on the open database session, so we depend on that. You can see that as the argument, it's injected by PyTest by its name that we overrode to be db_session. And we overwrite the dependency of our application to be this new database session and not the production one. And return a testing client, which is an instance of HTTPX client library ready to interact with your application. And now we write our first unit test. This will accept our HTTPX client class that's ready to connect to the application. We use it as you would normally, for example, the requests package. HTTPX behaves in pretty much the same way. So we do client.post to make a post request to our API at the snacks/snack route and include the JSON payload, which will be a new snack to create. So we specify the species length, that if it's venomous. We also set the API key header to a valid API key that we imported from our application code, and we accept this to succeed because we did everything right. So we assert that the return code is created and like 201, which is HTTP created response code, and we verify that there's a location for the snack that we just created, which will be like snacks/snack/DID. So we also assert that it should end with the snack/1 because we created the first snake. And so on for other unit tests.
Are there any questions?
Sure. If you couldn't use FastAPI, is there a close second that you would consider?
Well, depends on what you want to do with it. If it's just a JSON API, for example, Flask is a pretty good one. It also has an async.io alternative that I forgot how it's named. But if you Google like async.io Flask, you will find it.
I think it would be for me mostly about performance and having the specs in OpenAPI.
Yeah, so I don't know whether any other.
Django with a lot of tinkering.
Yeah, that's heavyweight. Yeah, you will probably have to do this on your own, the API specs and dependency injection and the database modeling and data validation with all the other like JSON API micro frameworks. And then the other one that's similar would be Django, which includes everything and kitchen sink. So yeah, FastAPI is probably the best option currently.
Any more questions? There's one. Go.
Is there some common use case for using tags in root definition?
Yeah, they're grouped in the documentation web page, the Swagger page. Not sure if it's shown here somewhere. Yes. Here they're separated. Here you can see the public tagged routes, which are these four. This grayed out one is the deprecated route. And here are the admin routes to create and delete snake.
So it's just about grouping the endpoints.
Yes.
Thanks.
One more question for this snake-infused talk.
Can you have multiple tags and then the endpoint will show up in multiple different groups?
Yes.
That was a quick one. Thank you very much, Patrik. And thank you everyone for joining us today in Python Meetup. And obviously we're not finishing just now, so you can go to the bar, bring your beer, and the networking part is about to begin, right? Unless we have a lightning talk. Hmm? We have a lightning talk. Do we?
Yeah, after a little break.
Okay, so we will have a break, have a beer, please come back, we will have a lightning talk, and then free networking.